Yeah, I should be recording this. So if you're going to do time on a flight as a two-part problem, and let me shrink this a little bit. So for part one, and I usually do part one or up flight, I have VI, I have VF, I have A, and I'd like delta T.
Isn't delta Y this?
Well, I don't know that yet.
Because we kept.
I don't know that yet.
Oh, okay.
I'm not going to use that. Because again, that's one where I would be relying on my own calculations, and I am, of course, notoriously prone to screwing things up. So I'll stick with the variables I'm given to the degree possible. Okay, what's my VI?
15.9.
15.9 meters per second, which is, by the way, a heck of a whale on that golf ball. Okay, so do I have something that connects these variables, VI, VF, A, delta T? Sure do. I've got VF equals VI plus A delta T. Easy peasy. VF minus VI divided by A equals delta T. So then for part one, what do I get for delta T? 1.62, was it?
What do you have?
What do you have?
Oh, yeah, sorry.
1.62.
What's the raw answer? Do you have that?
1.620.
Oh, okay.
And then it was a long number, I think.
Okay, so we'll say dot, dot, dot. Okay, so we've got 1.62. Now, if you're doing this as two-part, obviously you don't want to round yet. You want to wait until you're done. Now, part two is just a little bit trickier. Part two. Because here we have a VI. We know that VI is 0. We don't have displacement, but we could find it. We have acceleration, negative 9.81 meters per second squared. And we would like time. So how do we find delta y? Well, for that, we would have to go back to part one. And again, we can do a substitution. We can create an expression that will get us an expression for delta y and sub that in. Or we can just calculate the darn thing. So I've got my expression for delta y. I could actually just solve that for delta y. Actually, I don't want to use this. What do I want to use? I got delta y and I got VI. Oh, I got VF in part one. Well, okay, I can find delta y. So now I know how high it's falling from. It's what, 14.8 something you said?
Where'd it go? 14.385321.
Okay.
1.
385 dot dot dot.
Yeah.
Okay. So at this point, can I find delta t? Yeah. And I can even use delta y equals VI delta t plus 1/2 A delta t squared because VI is 0, and therefore that goes away. So that leaves me with a non-quadratic solve. So that means that I can add those two together and I'll get the total time.
Okay.
Does that make sense? And that should get you within rounding error of the same answer.
Yeah, I just used the original.